let's say you're planning some sort of study or survey or experiment or something, like you're in college and doing some research project, or you're in some statistics class, they're asking you to do some project. We're going to learn more and more things that you can do at the end of your project throughout the semester. Like, what do you do with the results? If you're going to make sure that you can do something with your results, then you have to make sure that all of your conditions are met before you even do your experiment, right? Okay, if I'm planning this, I need to make sure that everything, all the samples are in, or every person is independent. I need to make sure that I choose some sort of random sample. I use some sort of random experimental design or something. I need to make sure my sample size is less than 10% of the population, right? But then I also need to make sure I have at least 10 successes and at least 10 failures. Now, if you have just pre-decided what size margin of error you're going to allow yourself, then we can also figure out what sample size we might want. Okay? So maybe we're like, okay, at the end, I don't want a margin of error of larger than 8%. I'm only allowing myself some 8% wiggle room on both sides. Or maybe you want to be smaller than that. I only want a margin of error of 3%, plus or minus. Okay? If you already have that determined, and you pick some level of confidence, then if we have some sort of p, then we can use the equation from yesterday and solve for n. All right, so there's two things that can happen. One, they give you some sort of proportion to use in the question. So you could base your p on some other study that's already been done for some other age group, for some other population. Maybe it was about Europe and you went about the United States, or so you have some information about Europe, and we're going to estimate for the United States using that proportion. All right, so maybe we have some information already, and we can use for p. If not, the largest possible sample will always be produced by p equals 0.5. If you don't have any knowledge of what p might happen to be, then you go for 50-50. All right? So if you're looking at a question, because there's going to be both of those types of questions you have to answer today between the practice quizzes and the homework. If they give you some sort of p, use that. If they don't, use 0.5. Okay? So again, we have this equation. The margin of error is everything after the plus minus. So we're going to do one example, and then we're going to go on from there. It's believed that as many as 25% of adults over 50 never graduated from high school. We wish to see if this percentage is the same among the 25 to 30 age group. So I have a proportion for over 50. I'm trying to do a study for 25 to 30. So I may as well use this as an estimate as I try to figure out my sample size. On part A, it says, how many of this younger age group must we survey in order to estimate the proportion of non-grads to within 6% with 90% confidence? So I have all the necessary information that I would need except for the sample size. The margin of error is the critical value times the standard error. So what is my margin of error in part A? What is the margin of error I'm allowing myself? We're doing part A.
Okay, I didn't know if like the 6%.
Remember, it's plus or minus.
Yeah.
So it's, well, because it's plus or minus, it's just total. So 0.06. All right, we're allowing our margin of error to be 6%. We need to put that decimal. We want to do this with 90% confidence. So that one's one that's used quite often. So the critical value I already know is 1.645. If you don't know that, then how are you going to figure that out? Inverse norm, and what are you going to put in as your area? That's 50%. Yes, 0.05, right? Not 0.5, 0.05. So that'll give you 1.645. We're using a p of 25% because it's the best we've got. So 0.25 times 0.75 all over n because we are trying to solve for n. Okay? Now, your textbook might solve these differently. You can do it that way. I just think it's more complicated. I'm just going to solve this like you would any other algebra question. All right, if I'm going to solve for n, what would be the first step in this algebra problem?
divide by 1.645.
That's what I would do. Your book goes through and squares everything to begin with, which is fine. But as you square the 0.06, you have to square the 1.645, and then the square of the square root, then the square root goes away. But I think that's messier. It doesn't really matter. So 0.06 divided by 1.645 is 0.036 or something. Don't actually round this in the question. Use your calculator. So then what's the next step? All right, now you can square. So that's 0.001. And then what are you going to do? Min's getting competitive. So multiply each side by n. And then what are you going to do?
You're going to divide by 0.001.
Right. So 140.9, this is a sample size, so in this case we definitely have to round. So we're talking about how many people we have to survey. So 141. This counts for anything, like we are going to always round up. All right, so if it's at 140.03 people, we're still going to survey 141 people. Always think about the context of the question that you're answering. Don't round down because you're just in math mode. Okay? Questions about how I did that? All right, I'm not going to do part B and C. They ask you the same question over and over again, but with different margins of error. Suppose you want to cut the margin of error to 4%. What's the necessary sample size? You change 0.06 to 0.04. What sample size will produce a margin of error of 3%? So that's a different question. What sample size would produce a margin? Well, it's the same question, just they write it different, right? So 0.03 instead of 0.04 and 0.06. So this is not supposed to be super complicated, it's just a natural question. Again, keep in mind, if they don't give you a P, you have to use 0.5. This is a very, 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 very common AP multiple choice question. Super common. All right? They'll throw it out there and they ask for the sample size. They expect you to know what you're supposed to do. Any question? All right, then I just want to go over a few miscellaneous things really quickly. One is the what could go wrong section in the chapter. That's always there, and you should always be probably looking at it. I've said all these things. I'm going to remind you again. Don't misstate what the interval means. We went through all of those things that you shouldn't say. Again, I have essentially given you a script of what you should say about your interval, not because I just wanted to do that, but because that way you don't get yourself in trouble by saying things that aren't true. This happens every year. I give you a sentence to write, and then everyone's like, oh, I can be creative and make up something better. And then I'm reading it, and it's not correct. Okay? So, be very specific in what you're trying to say. If they ask you about margin of error, you need to make sure your margin of error makes sense. Like, don't have a margin of error of 25%. That doesn't help you out at all. That means you have an interval that's 50% wide. Right? What does that do? Nothing. Okay? So make sure your margin of error is small enough that it's still going to be a useful interval. And then make sure that you check your conditions. Don't assume that every single question that I assign you, all of the conditions are going to be met. Some of you did that last night on the homework. And so then you did the interval on the last question, but you didn't have to because the conditions weren't met. So don't assume they're just going to be met because I assigned you the question. All right? Make sure you're checking the conditions. On the AP exam, what they generally do is if they ask you that, they're going to say just to check the conditions. They're not going to ask you to construct a confidence interval. They'll just say, like, part A, check the conditions for inference here.
Okay.
And you'll check them, and it won't be right. And then part B won't have you construct an interval or anything. It'll just say, yeah, no, part B, like, well, like, so let's say the randomization condition wasn't met for an experiment. So part B would be like, design an experiment in such a way that the we would be able to construct a confidence interval.
They don't try to.
No, they don't try to trick you necessarily, but you still have to know the conditions.
Right. How do you recognize condition? I recognize.
What do you mean? How do you recognize the condition?
Like the one that always correct. Like randomization.
So again, randomization, you have to state that it's a random sample, or it has to be easily picked out that you have a good representation of the population.
Like how do you know that?
Like, for example, the chicken question yesterday. They said the chickens came from various stores in 23 states, right? So it doesn't outright say it's a random sample, but it comes from a variety of places. So you would assume they're trying to represent the entire population of chickens. They didn't say, I went to Kroger in Murray, Kentucky. Okay? Questions about that? All right. Then here's your homework / classwork. You have plenty of time. Page 457, 24, and 30. One of them is just another confidence interval to practice. 30 is more with this margin of error stuff to practice. And then I'm giving you practice quizzes.